We are looking at section 5.5. This is going to have to do with functions. What do we do with functions? Well, we can add them, subtract them, multiply, divide, and we can do compositions of functions. This is going to be a lot of stuff to learn, but then afterwards we're going to do a scavenger hunt. You're going to work in groups. You're going to find answers. You're going to be moving around the room. And I think that all of these different types of things we can do with functions will make sense after that. First thing you have to know, though, is how do we find the domain of any function? Well, first of all, our domain is going to be all real numbers from negative infinity to infinity, unless the function contains an even root. By even root, we're talking about square roots, fourth roots, sixth roots, eighth roots, or if it is a rational function. Rational means an x in the denominator. Okay? So again, if we have an even root or if we have an x in the denominator, we have to be careful with our domain. Otherwise, we don't. It's going to be all real numbers. For a function with an even root, the value under the radical must be greater than or equal to 0. We already talked about this a little bit. It's just like what we did on the homework. If you have a function, y equals the square root of x minus 3, and I ask you for the domain, well, we're not allowed to have a negative under there, so what would I say about the domain? Can I use 0? Would 0 give me a positive number? So what would I have to use? What kind of numbers? Well, but I'm talking about to keep it so that I have real numbers for my answers. What does the domain have to be, Siddharth? Yes. Can it be equal to 3? Yes. So I would say then that the domain here has to be from 3 to infinity. I'm staying away from imaginary numbers. I only want to get real numbers. So I could plug in 3, 4, 5, 3.1, 2.9 though doesn't work because it's not in this interval. Next one, for a rational function, the denominator cannot equal 0 or else the function is undefined. We don't want to have an undefined function. We want it to be defined. So if I gave you a function like y equals 7 over x minus 1, I want it to be a defined function. So what is the domain? What am I not allowed to use for x? 1 or 2? Which one? 1. I can't use 1 because if I plug in 1, what's 7 divided by 0? Undefined. 7 divided by 0 is undefined. So to keep it so that it's not undefined, I would have to say my domain, you can use anything from negative infinity up to 1 and from 1 to infinity, but don't use the number 1. You see how that would be the domain that would keep us so that we have answers. So we would not be able to use 1 here. We can't use anything smaller than 3 here. Any questions on domain? Those are the two things you got to look for. All right, scientific notation, this is so random. We're not doing that. I don't know why it's in this section. We're going to do this instead. So if f of x equals 4x minus 3 and g of x equals x squared plus 1, find f of g of 2 and g of f of 2. Now, in Algebra 1, I know you did a little bit of this, but you didn't do compositions of functions. This is a composition of functions. To do this, you ignore the f. So this is saying what is g of 2. You should know how to find g of 2. Plug in 2. What do you get? Plug in 2 for x. Instead of using x, use 2. 5. 4 plus 1 is 5. So the answer to g of 2 is 5. So now I'm doing f of 5 because the answer to g of 2 was 5. So now I have to come down to my f function, and wherever I have an x, I have to replace it with a 5. So 4 times 5 minus 3, what is it? So I would say then that f of g of 2 is 17. All right, so now we're going to do g of f of 2. Notice that this is not multiplication. Sometimes people think they should multiply g and f, but that's not multiplication. This is a composition of functions. Ignore the g to start. What's f of 2? Plug in 2 for x and the f function. Did you get 5? Okay, so f of 2 is 5. Now I'm doing g of 5. So I go to the g function. Wherever we have an x, we're replacing the x with 5. And so what do you get? 26. So g of f of 2 is 26. Do you see how we had the same x values in the same functions, but because we did them in different orders, we got different answers? Okay? So these again are called compositions of functions. These are called operations on functions. So if I have a function given of 5x, and I have a function given of x plus 2, if they ask us to do f plus g of x, that's the same thing as f of x plus g of x. So we just add these two. What do you get if you add those two? 6x plus 2, right? So it says. If I have f minus g of x, that's the same thing as doing f of x minus g of x. Here's f of x, here's g of x. You do have to be careful that when you subtract, you distribute this negative. So 5x minus 1x is 4x, minus a positive 2 is a minus 2. All right, now look at this, guys. Can you see why people might think that this actually means the same thing as that? Look at it. But see how it's missing that extra parenthesis there? So this actually means multiplication when it's written like this. So this means that I have to take my f of x function times that g of x function. So again, this is multiplication, and another way you can see multiplication is like this. Make note of that. All of these mean multiplication. They're not compositions of functions, it's multiplication. So you write them both, you multiply them out, that's what you get. Division looks like that, and we just do division f of x divided by g of x. All right, now what's the domain on this one though? What's the domain? Anybody tell me? Go ahead.
Or no, sorry, -1.
No.
Wait, no, it'd be -2, but it doesn't count as -2.
So we can use anything but -2, right? So you could say x cannot equal -2. That's the easy way out, though. How do we write it in interval notation? Siddharth? Right. That's a better way, yeah. I'll give you credit for it. Unless it says use interval notation, then you have to use interval notation. It's going to say use interval notation. All right. So, next part. The domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains for both f and g. Additionally, the domain of the quotient does not include x values for which g of x equals 0. All right, now this is all stuff that is not in your book. We're going to be doing some compositions. You have to know that when you have this open dot, look at the difference here, guys. This is a closed dot. This closed dot means multiplication. This open dot means f of. The open dot literally means of. Okay? So when you see f open dot of g, it means the same thing as f of g of x that we did up above. If you see g open dot of f, that means g of f of x. That can get confusing. Think of open dot as meaning the word of. All right, so use f of x equals 5x, and again, g of x equals x plus 2. We're going to find f minus g of negative 4. All right, so what this means is that I need to do f minus g and then plug in negative 4. It does not mean that I'm going to do f minus g times negative 4. All right, let me show you what this means. I have to do f minus g. What's f minus g, guys? 4x what? Plus 2 or minus 2? Minus 2. Now this is telling me that for x you have to plug in negative 4. So it's 4 times plug in negative 4, and that's negative 18. Look at the difference between the way this is written, where this is saying replace x with negative 4, and this. This is saying to subtract f minus g, but then at the end multiply it by negative 4. So this means something different. So I have to subtract them. That's what I get when I subtract them. But now I have to multiply it by negative 4. So what's that going to be, guys? So see the difference? This means we're plugging in for x. This means we're doing the subtraction of the functions, then multiplying by negative 4. What does this one mean? G open dot f of 3. Am I multiplying g and f? What are we doing? G of f of x. The O means of. G of f of 3 is what we're doing. Can you guys see that open dot back in the back? Blow that thing up there so you can see it. Open dot means the same as this. Where do I plug in first, for G or F? F. Always work your way from the inside out. So plug 3 into the F function. What do you get? 15. So this answer is 15. So now I have to do G of 15. So I look at my G function, and wherever I see x, I put in 15. What's the answer? 17. Good. You guys try this one on your own now. Everybody get it? Understand why it would be 0? All right. Okay, now, it seems like this would be easier, but it's actually harder. This is saying to do g of f of x. So this is saying g, but I can't really compute f of x. I just have to write down what is f of x. It's 5x. So f of x is 5x, not just 5, but 5x. Now, wherever I see an x, I have to replace that x with 5x. So g of f of x, that means in here I plug in 5x, is 5x plus 2. See how it's easier when you have the numbers over the variables? All right, now what about this? Does this mean that I'm doing g of f of x? Is this a composition or multiplication? Multiplication. So this is multiplication. So I'm going to do f of x times g of x. And that's going to be 5x squared plus 10x. Okay? So lots of new stuff there. Let's flip over on the back. So on the back it says in exercises 1 through 4, we're supposed to find f plus g and f minus g for all of these. We're not doing all of these. We're going to skip quite a few. We are going to do number 1 though. On number 1, we are going to find f plus g of x. So we have to add these two functions. Are they like terms? They have to be like terms. They are. So what's negative 1/2 plus 9/2? 8/2, which is 4. So I know then that f plus g of x is going to be 4 cube root of x. Now I'm supposed to plug in negative 1,000 for x. So that means I'm going to do the cube root of negative 1,000. What's that? Times 4, negative 40. I'm also supposed to write the domain. So I look at my original function and my end function. Are there any restrictions for any of those things? Any of these functions? No, because it's cube root. So my domain is just negative infinity to infinity. All right, we're going to skip down here to number 5. This one we're going to subtract. We're going to do f minus g of x. So I check to make, it told us to do everything for all of them, but I'm just not going to do that. It's too much. So we're subtracting, so we're going to do this function minus this function. Think about it. Anybody know? What's it going to be if I do this function minus this one? Go ahead, Nate.
8, 4 through x, plus 4. No, sorry, plus 3.
Yep. Everybody agree? All right, let's go ahead and write our domain. So we look at the beginning functions as well as the end function. Are there any restrictions? We look at our root. Are there restrictions?
Yeah.
What is it? Can't be negative, so how do I write it? Good. 0 to infinity.
Plug 1 in for x.
I'm going to. I'm just getting ready to. So now f minus g of 1. So the 4 through to 1 is 1 times 8 plus 3 is 11. Okay? Not difficult. All right, the directions say in 5 through 8, find f g of x and f divided by g of x and state the domain and then to evaluate. We're not going to do all of these. We're just going to do, let's do 7 as well. People have trouble with that. Let's do 6, 7, and 8. Okay, for number 6, we're going to do multiplication. Okay, so if I multiply these two, so I'm going to do 12x times 11x to the 1/2. So I'm doing fg of x. That's what that means, multiplication. So I multiply these numbers, that's 121. What would my exponent be? X to the what? 3/2, good. So there's my answer. Now I have to think, are there any restrictions on my domain? Well, what root are we taking, guys?
Isn't it 133?
Yeah. Thank you. 132. What's our domain restriction if we're taking square roots? Yep, so we have to go 0 to infinity. Okay, now I have to plug in my number 4, so fg of x, of 4 rather. So this means, what am I doing to 4? I'm going to take the square root. Square root of 4 is 2. 2 to the 3rd is 8. 8 times 132. Anybody good at that stuff in their head? If not, 1056. Thank you. And we got it. All right. Let's do number 7. Let's go ahead and do multiplication again on this one. All right, so we're going to multiply the numbers that are in front. What's 0.25 times negative 4? Negative 1, good, because it's 1/4. So I'm going to have fg of x is going to be negative 1. And then what do I do to my exponents if my bases are alike? Add them, so I'm going to have what? 2/6 and 9/6. So that's going to be negative 1x to the 11/6. All right, so domain restrictions. Yes, no? Is it going to be negative infinity to infinity? Nope. Yep, it's got to be 0 to infinity, doesn't it, because of that sixth root. All right, so now I have to do this. I'm going to plug in 1. So the 6th root of 1 is 1, to the 11th is 1. That's negative 1. All right, last one. We'll do division on this one. Trying to find that. So I'm going to have to divide these. So I have 36x to the 7/4 over 4x to the 1/2. So we have to do 36 divided by 4 is 9. What do we do if our bases are alike? What do we do with the exponents? Subtract. So 7/4 minus 2/4. What's that going to give us? 5/4. So this is our resulting answer. Now, domain is tricky on this. I want you to think about domain. Remember, you got to look at the beginning and the end and think of what the restrictions would be, if any. What do you think? We have restrictions, don't we? What's the domain going to be? You think a bracket? It actually has to be a parenthesis. Can anybody explain why it has to be a parenthesis? Go ahead. Let's go through, Brad.
Because if you plug in 0 for x on the bottom, you get an undefined answer.
Right. Back here, if I plug in 0 for x, that's going to be undefined. We don't want undefined. We want it to be a real answer. So that's why we're not allowed to use 0. Okay? All right, and then just plug in 16. What's the 4th root of 16? 2. 2 to the 5th is 32. 32 times 9? A number? Thanks. All right, guys. Calculator stuff now, just 2 more. This is a really neat thing we can do in our calculator. It says the graphs of f of x and g of x are shown. Which graph represents the function of f plus g? If we don't feel like adding functions, we can actually make our calculators do it for us. Everybody go to y equals. We're going to put in our f function, which is x squared minus 4x plus 4. Let's put in our g function, 4x minus 5. What do I want to do with those two functions? Add them. I want to add y sub 1 and y sub 2. Can you think of how I can do that? Ainsley?
If you move your alpha and then trace button and alpha.
Very good. That's one way. She's saying go to alpha trace, and there's y1, plus alpha trace, and there's y2. Anybody know where else you can find y1 and y2 if you forget alpha trace? Under vars, y vars. Remember that? Okay, so either alpha trace or that. All right, so now go back to y equals. We don't want to see y1 and y2. It's just going to make the graph look ugly. So I turn those off. I'm going to do a zoom 6 to get my standard screen. And here's what it looks like if we add y1 and y2. We get this function. So which one is that? B. So this one is when we add them. Obviously, this one's going to be when we subtract them. But let's just go back to y equals and just go here to y sub 3 and change it to subtraction. And here's what it looks like when we subtract. And see how it's the same thing? Okay? So this is kind of a nice way to add and subtract functions if you want to graph the result. Okay, number 10. The variable x represents the number of pages of a textbook to be printed. The cost C to print the textbook can be modeled by the equation C of x equals 0.2x squared plus 10. The selling price P of the textbook can be modeled by the equation P of x equals 0.05x squared plus 20. Find P minus C of x. We've done this. We're going to take our first function minus that second function. Notice I distributed the negative through both terms. 0.05x squared minus 0.2x squared is going to give me negative 0.19, or hold on, what is that? 0.15, thank you, x squared plus 10. So we have negative 0.15 x squared plus 10. That's our function. Now it's asking us, what does this represent? If we do our price minus our cost, what's that going to represent? Think about it. The cost that it costs us to print, profit, yeah. Profit for X books. Okay? Price minus cost is going to give us profit. Okay, guys, that's it for today.